Okay, on the topic here of transforming functions, what we're going to be talking about are just the basic functions that we were working with previously. The x squared graph, the absolute value graph, all those. So hopefully you got a little bit used to those and know a little bit about those, because those will come in handy, sure enough, as we go through here. Let's just start with our regular f of x equals the x squared function. And what we're going to talk about then is taking that function and making a new function, so to speak, out of it by adding, subtracting, maybe even multiplying some things. You may know, perhaps have a guess anyway at what's going to happen here, but that's why I've got the overhead projected up here like this, so I can show you what I've got on my screen here on the calculator. Yeah, what I thought I'd do is I just plug those in here, and you tell me what happens as we do things to this. So we've got x squared, all right, and we should know a little bit about that one. And then what I want to do is x squared plus 3, see what happens. All right, so I'm going to graph both of these and try that again. Okay. All right, so here's the x squared graph, basically, and then here's x squared plus 3, that function. And so we'll notice, whoops, if I could get my marks there a little better. Well, you see here, maybe harder to see towards the back or on the screen there, but it appears what has happened to the graph. Well, it appears that everything's moved up, and that is exactly what's happened, of course. And matter of fact, guess how many it has moved up? It's moved up 3. Yeah, it turns out that adding a 3 out here, out on the function, what that's going to do to the graph is it's going to move it up 3 units. And that's exactly what it did here. 1, 2, 3 is now, well, now this is the low point there. And so if you followed every point, the same thing would happen. Now it looks like it's kind of squeezed together here, but if you follow it point by point, this point that's at 1, 1 is now at 1, 4 instead. So how many did it move up? It moved up 3. And same thing at 2. 2, the point at 2 here, see what would be 2, 4, is now 2, 7. Okay? And so every point has moved up 3 units. They're all 3 units up, okay? All right. Well, that being said then, what would we might expect if I did x squared minus 3? Well, this is an easy one, because if instead I go x squared minus 3 and graph it, there's my x squared graph, of course, and now here's x squared minus 3. So we got x squared plus 3, here's x squared, and then the bottom one now is x squared minus 3. So just probably what we were expecting, right? If we have a minus 3 there on the outside, what's that going to do? This we say shifts it up 3, the graph, and this is going to shift it what? Down 3. Okay? So those are nice little features about doing things to the equation. Add a 3 on the end, subtract 3. So what would we expect here if I did an x squared plus 100? Well, that's going to shift it up, and it's going to be how much shifted up? 100 units up. So that's a pretty nice, easy thing. So that would shift it way off my screen. So I'm not going to do that, but that's what would happen, right? So that one's what happens on a changing the equation like that. Okay? All right. Well, let's go and take the x squared graph, and instead of minus 3, we're going to have minus 3, but please note this is different. Is this the same thing as we had previous? It's not the same. Why is it different? Well, previously I had f of x equals x squared minus 3, but the minus 3 is on the outside. Okay? That's the way I look at it. Whereas now, where's the minus 3? It's on the inside of the parentheses. Outside meaning it's outside the squaring. Here it's on the inside of the squaring. And so let's just take a look here. Hopefully, okay. Hopefully you're saying this is going to do the same thing, but let's see what it does. There's x squared. So here's my x squared. Here is the x and y axis. So here is x squared minus 3. Or y equals x squared minus 3. Okay? What happened? Well, it didn't move it down 3, did it? Whoop. Get it right here. Okay. Yeah. This does something different. This does not move, the minus 3 here doesn't move it 3 units down. Which way 3 units did it go? Went to the right 3. Yeah, because here, 1, 2, 3. Follow this 0, 0 point. That 0, 0 point now is over here at 3, 0. So instead of going 3 units down, the minus 3 took it 3 units to the right. Okay, so the inside minus 3 makes it go 3 units to the right. What might we think on that one? X plus 4 in parentheses and that squared. What do you think the movement there will be? 4 units, which way? To the left. Okay, so we're thinking 4 units to the left. Well, let's check you on that. There's x squared, and there is x squared plus 4. Yep. 1, 2, 3, 4. Minus 4 now is where that low point is. Instead of at 0, it's at minus 4. You're right. Okay. This is making the graph move 4 units right. 4 units left, sorry. Okay? All right, so that one's actually a little bit trickier than the other. On the other, when the minus was on the outside, that moved it down 3. Plus on the outside moved it up 4, up whatever the units were. On the inside, however, it might go a little opposite of what you might think. Minus goes on the inside, goes to the right. That will always be that way, but minus on the inside goes to the right. Plus on the inside goes to the left. Okay, so that will always be the case, but it is opposite what you might think. Okay? Now, the good news on this is that it works no matter what shape graph you're talking about, whether it's the x squared graph, whether it's the absolute value graph, whether it's the x cubed graph, doesn't matter. This transformation, the shifting stuff, works the same for those. Okay? For example, the x cubed graph x cubed plus 4. What do you think is going to happen? Well, x cubed does this, right? That's the x cubed graph. And so if I go back and put in x cubed plus 4, what's that going to do? What's your guess? Up, down, right, left? Up 4? That's right. Yeah, it takes the x cubed graph, which is here, and now the x cubed plus 4 graph is here. So everything is moved up 4. So like I was saying, it works the very same way. The movement, if it's on the outside, up or down. On the inside, right and left. Okay? And the other thing is, so the -2 is on the inside there, so that's a right or left. And a minus goes right, or does it go left? To the right. Okay. So I'm thinking to the right. So let's just verify that is what it does. But I think we got it. There you go. Okay. So here's your x cubed. I should draw those in. You see them there? So yeah, the x cubed -2 graph does come in here 2 units over to the right from the x cubed graph. Okay? All right. So to kind of generalize, let's generalize this. So here's what we're saying. For the graph of any function, one, if you add a number on the outside, the graph moves up that many units. Or if you subtract a number on the outside, meaning the outside of the function, the graph moves down. Right? Outside, up or down. Plus goes up, minus goes down. Subtract on the outside, down. Add on the outside, moves up. Okay? However, if you add a number on the inside, that's right or left. Or putting a number added or subtract on the inside is right or left. And adding a number on the inside, the graph moves left. Or if it's subtracted on the inside, the graph moves right. Okay? So that is the case all the way for any function that we've talked about so far. For any function we come across, this is what we do. Add or subtract a number. Well, it depends on where you add and subtract it, on the inside or the outside. This is called shifting, and this is how it works for the transformation of shifting. Okay? All right. So let's try a couple here without the nice little calculator and see what we would do. Okay? All right. So let's graph f of x equals the absolute value of x minus 5. And the only thing in the absolute value is the x. All right, so first of all, we're thinking what shape? We looked at this shape last time. What shape are we talking about? This is the absolute value. The shape is the V shape, okay? So I've got the V shape graph, and then I have the minus 5, and the minus 5 happens to be outside, so what's that going to do to it? Well, it's going to move it five. How many? Which way? To the right? Down. Yeah. It's on the outside. Minus on the outside makes it go down. Okay. Now, what I'm interested in, so that gives us a pretty good idea of what it should look like. So we've got the V-shaped graph, and we're going to move it down. You still want to hit some good points, though. Whether you take the absolute value graph and put points on it and then move it down or whatever, I'm still interested in getting points pretty accurately here. So, in this case, it's you're still looking at 4 or 5 points, something like that. Give me 3, 4, 5 points that are accurate, and I'm pretty happy. Okay. If it's -2 here, that'd be a +2 minus 5, so that's -3. If it's -1, absolute value of -1 is +1, so it'd be -4. 0, well, that's -5. 1 is -4 again, and 2 is -3 again. Okay. So I'm still looking for those sorts of things. Okay, with me on that? But what we should see is that graph, the V-shaped graph, down 5 units. Here's kind of the absolute value right there. So I should see that move down 5. 1, 2, 3, 4, -5. All right, let's see if that happens. -2, I'm at -3. Yep. -1, I'm at -4. 0, I'm -5. 1, I'm at -4. And 2, I'm at -3. There you go. All right? Okay, all right. Let's see. Same deal. Let's talk about the graph of f of x equals the absolute value of x minus 5. Everybody's got that one? All right, so yeah, here's the contrast, because this one, we've got -5 again, but it's 5. It's not on the outside. Here it's on the inside, right? So I'm meaning inside the operation. Absolute value, squaring, cubing, whatever the operation is, that's what I'm talking about, inside and outside. In this case, it's the absolute value, and -5 is on the inside. Well, that's going to shift it. If it's on the inside, that's we call it a horizontal shift, and the minus, that one's the one where it might go opposite what you might think. Minus goes which way? Goes to the right. horizontal shift, right or left, minus goes to the right. So that's what we should be thinking. Okay, well, now this brings up the point here. Since I'm shifting, let's think about it. I'm shifting this graph, the absolute value graph, 5 units, and it's going to the right. Where's this V, the corner of the V, where's it going to occur? Well, it's going to be 5 units, 1, 2, 3, 4, 5. The V, the corner of the V, is going to be there at the 5. With me on that? Why I say that is because if the corner happens at 5, these are fine, but the interesting corner, if you will, the interesting point happens at 5. So I might want to shift my my view here instead of -2 to +2 because kind of the center of the graph's here at 5 now. So that's what I'm saying. Let's just shift it, make it more centered up at 5. So 3, 4, 5, 6, and 7. You can do those others, but because of the shift, 3, 4, 5, and 6, and 7 will be more centered than the others. All right, so if x is 3, get absolute value of -2 is +2. X is 4, get the absolute value of -1, which is +1. 5, of course, you get 0. At 6, x is 6, we get the absolute value of 1, which is 1. And at 7, the absolute value of 2, which is 2. Yeah, so those are some nice points. 3, 2, 4, 1, 5, 0, 6, 1, 7, 2. All right, there you go. It was exactly what we thought it would be. All right?